welcome back to PostNetwork Academy. I am Bindeshwar and today we are going to explore one of the most popular and simple machine learning algorithms, that is nav Bayes, and we will use it to classify whether we can play tennis based on weather conditions. And basically this is a probabilistic classifier, which means it predicts the probability of a class given some features rather than just giving a yes or no answer. It is built upon Bayes theorem combined with a key assumption that makes the computation simple. The nav, it means that features are independent. So without further delay, let's get started. So nav Bayes is a probabilistic classification algorithm. As I have explained, it is based on Bayes theorem, and the nav, it means that independence. Suppose we have a feature vector x and a class y, and Bayes theorem states that find the probability of y given x, and this is the formula. I am going to explain what does it means. So here py given x, it is the posterior probability of class y given features x. P x given y, that is the likelihood of features given class y, and py, that is the prior probability of a class y, and px, that is evidence, and this is the same for all classes, and that can be ignored. That is in some textbooks or tutorials you might have seen, they do not consider px and it does not affect. Now nav Bayes assumption assumes that features are conditionally independent given the class. So it can be written as p x1 x2 given y, and that can be written as product of all features probabilities given y. Now this makes computation efficient, especially for high dimensional feature vectors. Otherwise we have to compute joint probabilities, and each feature contributes independently to the probability of the class, and posterior probability then becomes p class y given x, that is proportional to p probability of class y, and p xi given y, where I is from 1 to n. This is n features. If we have 4 features, so we will use 4 instead of n. Now to classify a new instance, we will find out this expression maximum value, and that would be the class. I will explain it numerically, and we will compute posterior probabilities for each possible class and predict the class y with the highest posterior probability. Let us see summary. Nav Bayes converts probability estimates into a simple rule for a classification. What are advantages? Simple and fast to train, because that is a statistics based or probability based algorithm, so that would be fast. Work well with small data sets. Again, if probabilistic algorithm, it will work with small data set. Effective for text classification. One tutorial I have also made to classify movie sentiment. Disadvantages: assumes feature independence, can perform poorly with correlated features. If features are highly correlated, it can perform poorly. Despite simplicity, very effective for many real world applications. Let us see an Let us see a worked example. So suppose we have n features x1, x2 till xn, and the target class is y. This is the usual, you can say, the setup for a classification problem. Step first, we will compute prior probabilities for each class y, that is py. We will compute likelihood. So likelihood, we will compute xi given class y, and formula is here, count of xi with class y, total instances of class y. So here, after computing for a new instance, we will compute the posterior probability. This is for a new, and we will compute posterior probabilities for all classes, and will compare, and the highest posterior probability is the predicted class. So summary of steps: compute py, probability of a class, compute likelihoods pxi given y for each feature, multiply likelihood and priors for a posterior, and select the class with maximum posterior. And I am going to take weather data set. So there are 4 features: outlook, temperature, humidity, wind, and class is whether play tennis or not, and there are 14 features. So x1, x2, x3, x4, and here play tennis, that is the class, so we will denote it by y. Now if you see, there are 14 classes, 9 are yes, 5 are no, and total instances 14. Now we will calculate priors. So probability of y, the value is yes, so that would be 9 upon 14, and that would be equal to 0.643, and probability no, that is y 5 upon 14, this is 0.357. Now if we calculate for a feature outlook, so for a sunny given s, that would be 0.022, sunny no 0.6, overcast yes 0.44, overcast no, that is 0, because for a no there is no in outlook feature, for overcast there is no class no. For a rain yes 0.333, and for a rain no 0.4. The same way we will calculate for temperature. For a hot given s 0.22, for a cool given s 0.333, for a mild given s 0.444. The same way, hot for a no given no, cool for a given no, that is 0.4, hot given no, cool given no 0.2, mild given no 0.4. And thereafter humidity. Humidity has 2 values, humidity feature has 2 values, high and normal. So given high, given class yes, value probability of phi is 0.333. Normal given S class 0.667. Probability of high given no class 0.8. Probability of normal given no class 0.2. And another class we have wind. So weak and strong, we have 2 values. So weak given S 0.667. Probability of strong given S 0.333. Probability of weak given class no 0.4. strong, probability of strong given no 0.6. So we will calculate each probability, remember. And what we need to find out? We will find out class for this instance. We have X15 which has outlook, temperature and another feature. This is the wind and this is the humidity. Let me check it. That is the humidity. So based on these values, we will find whether this class belongs to S or no. So we will plug all values for x1, x2, x3 and x4 and we will multiply. This is Py is equal to S and for x1, x2, x3, x4. So we are finding probability given S y is equal to S given x5, x15. Now we will find it here and thereafter final probability. Probability of P S given x15, that would be 0.00525. The same way we will calculate for no. So here this is the P y given no, this is the P y given no, prior you can say that, and these are the likelihoods. Now if we calculate, so we will find it probability that no class is given x15 instance, that is a 0.026 and we will compare. So if we compare probability of class S given x15, that is a 0.00525 and probability of class no given instance 15, that is 0.026. So if you compare, these are the posterior probability. If you compare, so no is greater than S. So the fifth instance is classified as no. So the class has instance 15, that is no. So summary of steps, you can say that compute priors, compute likelihoods. These two are very important. Multiply likelihoods and priors for posterior and select the class with maximum posterior, and that would be the prediction. So hope you understood. If you want to reach PostNetwork Academy, go to website www.postnetwork.co, YouTube channel you can visit, Facebook page, LinkedIn page and GitHub repository. So hope you understood base theorem and practical example. Thanks for watching.